reactivity of alkyl halide and aryl halide. That means which one is more reactive, alkyl halide or aryl halide? This is continuation of the previous lesson. In this lesson, we are going to learn which one is more reactive and why. So let's get started. Alkyl halide. Suppose ethyl chloride. When ethyl chloride is treated with sodium hydroxide and silver nitrate, and the reaction mixture is heated, then this carbon chlorine bond undergoes heterolytic fission to form silver chloride, which deposits as white precipitate, and byproducts are ethanol and sodium nitrate. In this reaction, this carbon chlorine bond undergoes heterolytic fission and silver chloride is formed, which deposits as white precipitate. Again, let's see about aryl halide. Suppose phenyl chloride. When phenyl chloride is treated with sodium hydroxide and silver nitrate, then like alkyl chloride, silver chloride is not deposited as white precipitate. In case of aryl chloride or chlorobenzene, drastic condition is required, like 300 degrees Celsius temperature and 150 atmosphere pressure. At this drastic condition, chlorobenzene, here carbon chlorine bond undergoes heterolytic fission, and after that silver chloride deposits as white precipitate. Here byproducts are sodium phenoxide and nitric acid. Simply we can say that alkyl chloride or alkyl halide forms silver chloride precipitate at normal condition, but chlorobenzene or aryl chloride forms precipitate at drastic condition. These reactions mean that this is less reactive than this one. That is, this bond undergoes heterolytic fission easily, but in case of chlorobenzene, this bond undergoes a heterolytic fission laboriously. What is the reason behind this? Let's try to clarify the reason. Ethyl chloride. Here, this carbon chlorine bond is a straight single bond. But in case of chlorobenzene, in benzene ring, all the carbon atoms are sp2 hybridized. So all carbon atoms contain unhybridized p orbital. All 6 carbon atoms with 1 electrons. These unhybridized p orbitals overlap with each other and pi molecular orbital is formed above the plane and below the plane. Through this sidewise overlap of unhybridized p orbital, makes benzene ring stable. When this carbon is linked up with a halogen like chlorine that contains p orbital with lone pair of electrons. In chlorobenzene, this p orbital overlap with the unhybridized p orbital of benzene ring. That means this p orbital with lone pair of electrons join the pi molecular orbital of benzene ring to form extended pi molecular orbital. Now, 6 electrons of 6 carbon atoms of benzene ring and lone pair electrons of halogen form continuous pi molecular orbital, and as a result this carbon chlorine bond becomes stronger. As p orbital of chlorine joins the pi molecular orbital of benzene ring, carbon chlorine bond becomes stronger. Simply we can show that in chlorobenzene this bond changes to partial double bond. That is why this bond becomes stronger compared to this bond, carbon chlorine bond of ethyl chloride. For this reason, ethyl chloride forms silver chloride precipitate very easily, and as this carbon chlorine bond is stronger, that is why in case of chlorobenzene, silver chloride doesn't deposit as precipitate very easily. Rather, it requires drastic condition. So we can say that ethyl chloride is more reactive than phenyl chloride. So we can write here alkyl halide is more reactive than aryl halide. In alkyl halide, this bond is straight single bond, but in aryl halide, this carbon chlorine bond gets partial double bond. Because of this, aryl halide requires drastic condition, that is, it is less reactive, but alkyl halide requires normal condition because it is more reactive. So alkyl halide is more reactive and aryl halide is less reactive. No more today. Thank you very much.